Good morning, everyone. Good morning. My name is Torsten. I'm going to be your host this morning, and I'm really looking forward for exciting 2 hours of really Kubernetes security hands-on. One of my panel colleagues, Gerland, is already there. Good morning, Gerland. We'll wait. It's now 1 minute to 10. We'll wait a little bit so everybody can be joining. Hi, Gerland. Hi, Thomas.
Hi, Torsten. Good morning. Good morning, everyone.
Good morning, everyone out there. We have, I just looked 3 minutes ago, and we have 104 people who registered for this workshop. I think for a workshop, this is an amazing crowd. Let's see how many people really show up and only want to show off that they like the whole thing. So let's see. So we'll wait. It's not 10 yet, and we have 11 people already in the viewer section. So for everyone who's joining, what you see that in my background picture, that all the slides and all the video recordings will be available to all registered participants. If you haven't registered, just let me know or send me an email or put that in the chat. Send me an email that you want to have these collateral as well. Just let me know. What we'll do is there will be 3 30 minutes walkthroughs, workshops, hands-on workshops, and after that we'll have 30 minutes of Q&A. You see that down in your Zoom meeting. There is Q&A. There's a Q&A sections. If you have any questions, please write them down there. We'll answer them accordingly in the Q&A session at the end of the whole workshop. And if you have any other question, just put it in the chat and we'll try to answer that as well if it's just more organizing stuff. If you have technical questions, just put it in the Q&A session, please. So we're now at 21. So we'll really start at 5 past. So we'll give everybody the chance to log in and see. The first one to start will be Gerland. So now we're waiting for our third panelists, Mickey. Ah, there he is. Hi, Mickey.
Hi. Hey.
So, welcome everybody for this Kubernetes security workshop. We're really looking forward for 2 hours of digging deep into the security side of Kubernetes. We'll have 3 great speakers with us. It's Gerland first, Thomas second, and Mickey third. What we'll do, Gerland will go into an open source tool which is called Kube-Scan, and he will show you how security and Kubernetes are put together and how you can see how secure your environment is. Thomas will go and show you a little bit how to hack the whole Kubernetes, which you might have or not. And last but not least, Mickey will show you a product which helps you to mitigate this from the beginning. So we've got 25 people already in the crowd, 26 and up and running. So everybody, get yourself a coffee, get yourself something to drink. We'll start 5 past, so in another 2 minutes with Gerland. And for everybody who just joined, we have a Q&A section. In the end of the workshop, the last 30 minutes, we'll run through Q&As. If you have any question, write that down. If you have any organizational questions, please put them in the chat and we'll try to answer that during the workshop. We'll start in 1 minute with Gerland, and 30 minutes later, Thomas will do his speech, and then Mickey comes along, and then we'll have the Q&A session. So 28 and rising, let's see. Welcome, everybody. If you've been to our webinar meetup last time, 3 weeks ago, the recording is on YouTube, and you can look for GlobalDots on YouTube and Kubernetes, and you'll see me and the other panelists, except Mickey. He was not there. It was Ram last time. So, and we will do the same thing here, but we'll send you a link for everybody who's registered. Who hasn't registered, please send me an email and I'll get you the stuff. So it's 5 past 10. Good morning, everyone. Welcome to our workshop. Our first panelist will be Gerland. Gerland, I'm handing over to you.
Yes, and thank you.
Please,
good morning, everyone.
Go ahead.
From my side, so let me share my screen. So is my screen seeable now in
Yes, I can see it.
Full screen, so okay. Yeah, so good morning, everyone. Before we start, just some words to introduce myself. My name is Yulin Budurushi. I am currently head of security at Cloudical and also a lecturer at the Cooperative State University of Baden-Württemberg. My project areas for the moment include data centers, software development, and cloud service providers. I focus mainly on the security in the cloud native ecosystem, especially on Kubernetes, and also providing some security webinars and training as today. And at the university, currently I lecture IT security. Today I'll talk about risk assessment with Kube-Scan. And the agenda looks as follows. I will give you a very short background on what is actually risk assessment and why it is important. Then in the second part, we will look and try to understand what is Kube-Scan and what it does. After that, we will have a short demonstration showing you how easy it is actually to use Kube-Scan and how this can help you to improve the security in your Kubernetes environment. And before I hand over to my colleague Thomas, I will also try to motivate you to understand why security is actually bigger than, greater than just risk assessment. So let's start with the background. What is actually risk assessment? So risk assessment is the determination of quantitative or qualitative value of risk to a concrete context and identified threat. So it is a process actually where we start by identifying the risks that are important to us, assessing them, trying to give them a value and to understand how they are important to us, understanding how we can mitigate them, so mitigating and putting controls into place and trying to mitigate and minimize the risk. And of course, at the end, we need to monitor and to see if the controls that we have put in place are actually addressing those risks that we have identified. And why it is risk assessment important? First, we need to create awareness of the threat and associated risks. In the second place, we need to understand and identify who or what may be at risk. The next step is that it allows us to determine if current control measures are adequate. Something that we have already in place as a security control. Is this adequate enough? Is this actually addressing the risk that we are put on as we want to have it addressed? Next is we want to prevent damage. So we want to prevent damage of losing customer data, of losing personally identifiable data, and of losing also the image of the business or the company. And of course, this also helps us to prioritize according to business goals. It is for sure also common knowledge that not all of the risks that are out there can be let's say addressed at 100% or all at the same time, but you need a strategy and you need to prioritize those depending, for example, on which are the highest risk to your business and then addressing those first and so on until you have a good landscape of view of the addressed risk that you are currently facing. So let's go to the next part and try to understand actually, so what is Kube-Scan? So what is actually Kube-Scan? So Kube-Scan is an open source risk assessment tools for Kubernetes workloads, which have been developed by Octarine. The project page you can find, I put here the link, so later you can have a look yourself even after this workshop. There you find the project, and you are also welcome to contribute, as this is a community supported version. So what it is, Kube-Scan in all, what it contains a single pod. It includes a scanner, it includes a scoring engine, and of course a nice web UI where you can read and use this as easy as possible to understand the risk landscape. So it's not on the CLI level, so it's really helping you out to make things visual to you. What does Kube-Scan actually provide? So it provides a risk score for each workload, and there is a scale from 0 to no risk, depending on the configuration of the workload and the configuration settings of your cluster, or a 10, which means a very high risk, meaning that this is, let's say, later we will see, meaning that this is very easy exploitable, and you should take care of this risk and you should try to mitigate this risk as soon as possible. The scores that are provided, meaning the 0 to 10, are based on the runtime configurations of the workloads. And currently there are more than around 30 configurations that you can set up into your workloads. To get an overview of what configuration have been set up and if they were set up correctly, or to help your employees to understand how to set this up correctly, this is a very nice overview, because imagine you have to do this by yourself, or your developers have to do this, which have actually a different primary task in their daily work. The scoring is based on a Kubernetes common configuration scoring system, which we will talk about this in the next couple of slides. The question is, so how it is the assessment done? So how does actually Kube-Scan do the assessment? It takes the security configurations, for example, looking at including privilege levels, capabilities, the policies that you have set into your environment. So it takes all of this possible and available configuration and looks at them and sees how they have been configured. And the good thing about it is it doesn't look at one configuration solely, so it doesn't assess one configuration and what is the impact of this configuration, but it also combines this configuration or the impact that different configuration might have with respect to security into your current environment. And the assessment criteria, so what is actually assessed, so what it gives you as an output, because this is the most important part, it's the exploitation, which means does this threat, can this threat be exploited with local access, or can it be exploited, for example, through the network and an external network? The impact, meaning what it does impact. So it impacts confidentiality, it impacts integrity, or it impacts availability of your cluster. And the scope, meaning that if the risk that you are facing on, it is scoped to your node, to your host, or to your workload, and to your cluster. So this is also important to understand the radius of the risk. So after that you have identified that you are at risk, you will ask yourself, so what now? So what can I do? And actually, I would suggest to follow this step. So you first need to thoroughly understand the risk landscape. So the risks that are shown by Kube-Scan, it gives you the first basic to work on that, and you need to understand this risk that I provided to you. Second, you need to evaluate the risks, not solely, but also in combination. As the Kube-Scan is supporting you to do this, you should do the same when you evaluate the risk and what do they mean actually for your business. And last but not least, you have to prioritize the risk and define adequate treatment strategies, meaning that you need to understand how and what controls actually are adequate to mitigate and to minimize those risks. So you might have to accept some risk, you can delegate some of them, or you can try to mitigate some of them if adequate control measures are out there. The question is here, who is the enemy? Because when we talk about risk assessment, it's very important to understand also about who is the enemy. So you need to understand who are you actually protecting yourself and who is putting you into risk. And this can be anyone with specific knowledge and skill set in the first place. The question here that rises is, of course, is Octarine 2, the ones that have developed this open source tool, also an enemy or a threat to you? And the answer is here no, because Kube-Scan is implemented as such that no data leaves your environment. So all is contented into your environment. You are the only one being able to see the content and to understand your risk landscape, and also to have this knowledge only for you, because if this knowledge has to be put out there and everyone else have this knowledge, then you will be, of course, in a bad situation. And of course, here you have always to consider internal and external attackers. And I just borrowed this. I saw this a couple of days ago in the Cybersecurity Hub, and I find this very fitting in here when we need to consider internal and external attackers. So everyone who works in your company can be an attacker, and everyone else who doesn't work there can be a threat to your environment. So let's talk a little bit about the Kubernetes Common Configuration Scoring System. As this is, let's say, one of the main components and most important parts of Kube-Scan. This is an open source framework which rates risks of misconfigurations for Kubernetes workloads. And this provides you a standard method for determining the risky workloads. And most important is that you have afterwards in your environment, in your company, you have a common language and understanding across the teams. So you have different teams, the developers, and you might have security teams, and you might have operational teams. And this using a standard framework for trying to understand the risk landscape, it helps you to have a common language and a common understanding and to better mitigate the risk that you are facing to. So aren't there existing scoring systems? Yes, there are existing scoring systems, but they are not specific to Kubernetes. So this is something new into this area, and this is addressing exactly the platform that you are dealing with into your everyday work. So still, the Kubernetes common configuration scoring system, it's not something, let's say, reinventing the wheel here, but it's something that is inspired by the common vulnerability scoring system, which will give you vulnerabilities with respect to software flows and bugs that can be intentionally or unintentionally in different software packets. The configuration scoring system, which is the one that the Kubernetes common configuration scoring system can be, let's say, it's most inspired on. And of course, the enumeration, which gives you the possibility then to understand if, let's say, best practices have been implemented in an automated way. So all of this has been combined. All of these three aspects has been combined and has been put together by the Kubernetes common configuration scoring system, which is an added value in here for your environment. So what security goals are considered in this scoring system? As I said before, confidentiality. So we see if any exposures of personal identifiable data is happening, secrets, etc. Integrity, meaning if any unauthorized changes are happening to your containers, the host, or the cluster in general. And availability, for example, if anyone is trying to conduct a denial of service attack against your environment, or has put a malicious container on there that is trying to do some Bitcoin mining on your resources and on your pocket. And exactly this is one of the use cases that we are going to see later with Thomas, and he is going to show you how this actually can be done, and that can be also something that it's easy to prevent, which then Miki will discuss in the third talk. So the criteria that are considered here in the scoring system, we said before, it's exploitability, which is the probability of the vulnerability to be exploited, meaning how easy it is actually to exploit the vulnerability. The attack vector, meaning if it's remote or a local attack possible on the current configuration set. And the scope. So does this threat or risk that you are facing impact your container? It impacts the host the container is running on, or it impacts the entire cluster. The anatomy of rules in here on that is they are extensible and described in YAML. As this is open source, you can extend those rules by yourself, and you can adapt them as fit to your environment, or as fit as to your requirement and compliance requirement that you have in your company. You have the risks, which are set up, and these are the likelihood of the workload to be compromised. And you have a remediation, which meaning configuration setting to minimize the likelihood of a workload to be compromised. So this is a very important thing here to be mentioned, and which we are going to look into the demo after this, is that you have also a remediation, meaning that Kube-Scan, it does not only show you the risk, and it does not only give you let's say a score on that risk, on how important this risk is or how severe this risk is, but it also provides you, let's say, remediation strategy and how you can improve to minimize the likelihood of this workload to be compromised, which it's helped you in the first place to understand the risk even better. So overview of the source codes. I would like to go now a little bit into the project themselves. So let me go first to Kube-Scan. So let me go to I'm clicking to the wrong one. Where the YAML file I'm searching for. So here's the YAML file that you can see what Kube-Scan is actually including. And here you have the risk configuration, the values that have been set and have been suggested as first by Kube-Scan itself. Of course, as this is open source, you can, as I said before, you can fit this and tailor this to your own compliance requirements. There you have the risk and the remediation. In here, for example, you have the description, you have the impact, so what it impacts, like for example, confidentiality, the integrity, the availability, the host, and if this is, let's say, is privileged, it means the risk that you are facing on. And this is already provided by Kube-Scan. You can go and have a look later for yourself. So it's very simple and easy to understand in here. So this is what actually Kube-Scan offers you, what the main part of Kube-Scan is providing. Let's look at the common configuration framework. So let's look at it in the code. So let's go and to have a look at the rules that it provides. So here you have the risk and the remediation, as I was mentioning before. Let's go to the risks, and let's say, like for example, let's take the privileged one, as we said before. And here you will see, for example, the workload is privileged. So this would match the one that we saw before in Kube-Scan that was put in there into the YAML file. And it gives you the description of that. And it gives you, again, the availability, confidentiality, integrity, what is actually, how is this has been rated by Kube-Scan, the scope of it, the attack vector, if this the risk or this threat can be exploited externally or internally. And of course, what it is most important, which this is very helpful and useful in here, is the remediation. So for example, in here, it recommends you that you need to restrict the capability of KCCSS admin into your workload, for example, and it provides you even the configuration, so where you can do this, for example, and provide only these capabilities you need, and not provide the full capabilities into your environment. So let's have a look then. So the next we'll do the demo. So bear with me. I've been so I got the right password. No, this is not the right password. No, I think it copied the right password. Yes, so we are mostly logged in. It takes a little bit, but we made it. So I have prepared just a very small environment in here. So I have installed here micro Kates from Ubuntu, which, as you see, it runs on a virtual machine, and it helps you also maybe to for your whatever deployment and development environment when you have to understand and to see and to play around with a couple of tools. So let's see if this is running. So it's running. Get some pods I have installed. Very spaces. Yeah, so if we see here, so I have installed this Hello World example and the bootcamp example in here. So just for the sake of the demonstration, and I have copied the, so all what you need to do in here to install Kube-Scan is to apply this YAML file into your environment, and the rest will follow, as you see. So then so in here we can copy the IP address. You see that the Kube-Scan is already running. Let's go to the web browser. And copy this, and there you go. So this is what you see. You see that it recognized already the two pods that are running, and it gives you a risk score of 5, for example, in this case. It provides you with information like Kubernetes Bootcamp is the resource, the cluster name, if you put in a namespace and the kind that it is, and here below you find the different kind of risk that this workload is facing on. Like, for example, the workload, it has containers running as root. If you show more in here, let me maybe just make this a little bit smaller. So I hope it's still good readable in here. You have, for example, the integrity impact, so it which is low on this. The confidentiality provided as high, and the availability. So these 3 values would provide you with the impact. You have the exploitability, which is saying to you if it's likely or not likely to be exploited. The attack vector, so it's saying the local access is actually required to attack or to compromise this workload, and also the scope, which is the impact on the node. This workload is running, and it provides you some description on that and how you can actually do remediation on that. So in that, it's providing you a couple of useful information, and this was very fast. You saw, so I just installed the Kube-Scan, and it already give you an overview of the workloads. So it's not only because this is 2 workloads, but even if you have many workloads, this would work for you in a matter of seconds. So again, in here, this is how you can have a look at that and how you can use it. And after that, so if you have to bear in mind that if you are installing other workloads into your environment, so Kube-Scan currently, it won't recognize them, but it will rerun again after 24 hours. But nevertheless, so if you want to have the risks overview of your current workloads, you need to deinstall and to reinstall the Kube-Scan workload. So, and to deinstall this, it's also very easy. So you just delete the environment, the pod, and that's it. Yeah. So this is going to be deleted, and let me go back again to the presentation. And just go with you through the last part. So why actually security is greater than risk assessment? This should have been obvious right now, exactly what I just mentioned before, that even after you do a risk assessment, and if this risk assessment is only static for the moment, it's not continuous, you are not going to be secure. So security, you have to have a holistic view on security. You don't have only to focus on Kubernetes, but you have to have a process in it which it accompanying you to the DevOps concept, and it introduces security in there throughout the different layers, the so-called security in depth. Or security by design. This is the way you actually have to look at security, even though these tools are out there to help you do this even in an automated way. So at the end of the journey, so it's actually your responsibility and duty to understand, depending on your computing model that you are using, so you have to understand your responsibility, so where you actually are starting to be responsible for the security. And on the other hand, you have to understand your risk landscape. So understand what are the risks that you are facing on, and you have to implement adequate controls. And these are very handy tools that will help you to do this in an automated way. With that, I thank you for your attention, and I will hand then over to Thomas.
Well, thank you so much, Gerland, for this first overview. Guys, if you have any questions, please put them in the Q&A sessions, or in German, F&A section in the Zoom meeting, and we'll answer that after all three panelists have held their talks. So thank you for telling us about Kube-Scan. Now, Thomas, what's out there? Why should we be afraid, and what can people do? Please show us.
Yeah, so thank you, Jolyn, for the introduction. I will talk about a real exploit which popped up 1 year ago, and now it's still exploitable, and it's as simple as it can be. So 3 steps to hell, and what you should prevent and how we can try to avoid this. So I will introduce you to a short presentation, very short, and then we will go hands-on. I posted the link to the presentation into the chat. So, and at the end there are the commands you can place on your own in Minikube provided. So, and then we will share all the resources. So what's going on? If you don't know me yet, this is my CV. So I have been CTO at Endocode. Now I'm partner. My business is system automation, DevOps, cloud database, software architecture, Kubernetes since 2015. I'm a member of the Octarine Technical Advisory Board, working in AG Kritis. So in Germany, they are caring about critical infrastructure. Did a review for Gaia X. And at the moment, I'm in a project in critical infrastructure, which is very critical, believe me, but I cannot talk about it. And it's in the energy sector. So what we see here is just to get away from all the illusions, all clouds are broken. So more or less, if you don't care about security, the cloud providers don't do it for you. They give you a minimal set of security, but then you are on your own, more or less. Last time we had this least privileges thing, which is, if you don't apply it, it's a recommendation to keep it as simple as possible and keep the entire stuff auditable. And today we will talk about one example of Kubernetes standard no security. By the way, this is a Kubouterman, I called it. I created it from good old yeah, let's Pirates of the Caribbean and Star Wars and other things, because it's so mixed. You can do a lot with Kubernetes security, and it's easy to lose control completely if you don't know what you are doing. Let's change to the hands-on session. So I have prepared a Jupyter lab. The commands actually are here in your slides, and you can copy them step by step or page by page if you have prepared a Minikube. What we want to show is how easy it is to take over a cluster. So owning a cluster from an untrusted source is possible if you give it root privileges and access to the host file system, which is not prevented in the standard cloud provider. So we are using Minikube here, and I'm starting a Minikube session now. If you have not a Linux operating system with a VM driver KVM2, leave it away or use your preferred Minikube hypervisor, then you can get it. Please don't do it on a production machine, what we are doing here. I'm using 1.8.2 because it's simply what I've tested on. There are new drivers for 1.9 and I didn't have the time here. We are using Minikube, but believe me, a very similar attack is still working in most of the major clouds. So I just rechecked GKE. So in GKE without pod security policies, you get very similar results. And I'm just starting the virtual machine, waiting for you. This can take some minutes. Yes, I'm looking into the group chat. If you are using VirtualBox, leave away the driver option. So this is something which is a recommendation here. Take some minutes, and then we have it up and running. So let's wait. And in between, you can see here, this is exactly what we want to do if you have a different operating system. Don't do it with a KVM2 driver, which is very Linux specific. Still creating, now preparing Kubernetes, launching Kubernetes. I like the Jupyter notebooks with a bash kernel because they have all these emojis, which are not shown in the standard terminal. I have to update my Ubuntu below that. I'm not doing it in VM driver none environment because the actual attack will tear down the virtual machine after a while. Okay, it's done. So we should be able to get the cluster information, and we have it. So we have a local cluster and it's running. And then the next step is we import the Minikube Docker environment. This is another thing what I noticed in actual workload environments, developers tending to expose these ports to the network. And here it's a virtual network inside my computer. It's not a security risk, but this also can be a security risk if you do it on a real machine and expose it to your company internet, or even worse, to the global internet. I evaluate it, then we get access to the Docker inside and are creating yeah, we are using the Docker system inside the virtual machine. So we make an empty directory. It's just existing, so we do that. We are in that directory now, and we should clean it. Yeah, it's just to fix it, just to make it clean. Execute it again. So here we are, and there this works. So the next step is we download a statically linked version of Docker, because I already have published an exploit which simply is using the Docker of the hosting Kubernetes worker node, which does not work anymore because the versions have diversified. So stable Docker version, statically linked, is available from Docker. So we download it using curl. The version does not really matter. So we have a version here, and inside that version, we have Docker binary, a container D binary, CTR, Docker D, runc, and so on. We are focusing on the Docker binary. So we are using extraction. So we are extracting a Docker tgz. And now we are creating a Docker file. By the way, we are using the Docker environment in the virtual machine. So we are using this, and it's as simple as it can be. That's not true. It could also be a static, or it could also be a binary from scratch, but an Alpine has a minimal shell environment in it, and we will use it later. So we are using these lines of code to create a Docker file and show it. 3 lines of Docker file. We can look if we really get a connection. Yes, this is a connection to the virtual machine. So you see most of the services are also in containers. And this means if we have control to the Docker socket, we have control to the Kubernetes worker node and can control it completely. So we effectively own it this way. Let's build the Docker file and tag it with a name. It's Cloud Bomb. We are using it only locally. I don't want to push things like this to registries, because then it's a real script kiddie attack. So this is a script kiddie attack, believe me. And we are using it. It's pulling Alpine immediately. So we have a Cloud Bomb image now in our environment. We can go back and see it. So we have downloaded Alpine, created Cloud Bomb. That's how it is. Here, this is the line I wanted to show you. Yeah, you see the Cloud Bomb. This grep -e is only just for the colorings. This is quite nice. Doesn't have another meaning. So the next thing we do is we create a pod from this image. And pod means we need this image, and we are doing a little bit of scripting around it. So what we do here is if we get access to the Docker, we create Nginx images, Nginx because it's whatever the guinea pig of Kubernetes, so it's available everywhere fast. We can use it, and then it's just simple. We are using a Bourne shell because Alpine doesn't have a bash. We use Cloud Bomb here, and what we do is, and what is the dangerous part and should prevent it and checked in every production environment, is we import the host path via run Docker sock. So this is the Docker socket of the worker node, and if we get access to the Docker socket on the worker node, we own the cluster, period. And this is what we are going to do. and just starting the pod. There is one more option. If not present simply means it is using, is it checking if the image is already present on the machine and it's not trying to download it, because I already said I don't want to spread it and going viral, because then this kind of attack could be common because it's so easy. So we have a cloud bomb pod running, and we could wait here. So condition is met. We see the pods, and we can look. We don't need to sleep here. Talked enough. We can see the logs of the cloud bomb, and it's downloading Nginx. So and it tells me yes, something is going on here. And as I said, we are trying to own the cluster. Let's see if this works. We have here, I'll make it a little bit smaller. We have this Nginx with a boom name and a random number at the end. We have taken over, we are owning the cluster at the moment, and the cloud bomb is very slow because I want to talk in between. But you see in parallel, outside the control of Kubernetes, we have started Nginx images, and they are running, they are using ports and so on. So this works, and they are increasing. So we have 5 now, and in between we have 8. So slowly the bomb is exploding and taking over the load on the cluster. And this is what exactly I don't want to allow, because this could be the Bitcoin miner, this could be any malicious hardware. And you don't see it in Kubernetes. You don't see it with standard kubectl. You only see it if you in parallel control the Docker socket. So this is something which should not be allowed. And the answer is, of course, pod security policies don't run things as root. If you would have applied one of these rules, only trusted sources, no root privileges, and no access to the old file system, or using pod security policies additionally, then this is virtually impossible. But the default in the clouds definitely is an insecure version of this. So we see every 10 seconds and Nginx is created. This is how it works. Okay. So we have an exploit, and let's see how Kube-Scan scores it, how it works together with this, if this is a reasonable tool. And the answer is yes, but we will see how the rating is. So we apply the Kube-Scan master. We are waiting until it's ready. It can take a few seconds because the virtual machine always is fresh. It's downloaded from the network, which is not really a problem. And after this is ready, we use a GUI, the graphical user interface, to score and see the score. And so we are running it, and it's not up, it's not ready. Ah, I forgot something. Of course, this is live. We didn't apply Minikube tunnel here, so we have to do it in a parallel session. So please start a Minikube tunnel. Then it will get an IP address. Just wait a second. Okay, let's see if we get an IP address now. We have an IP address. So it's a standard service, and now we can look up the service and the scoring. Which is a 5. This is good, but obviously the risk medium is not enough, I would say. Workload has containers with network capabilities. So this is something which doesn't affect us at the moment. We didn't configure CPU limit. Privilege escalation is still possible. Writable file system, this would be another thing. At the moment, I have put the exploit, the offending Docker binary into the container. But obviously, if you have a writable file system, you can get access to the container somehow, you can download it. So this is relevant, but this is not something I would say, I would give it, if I would be asked, I would give it an 8 or 9. So this is effectively an attack from the inside. You need access to kubectl, so you must be able to deploy workloads in the cluster, but you don't have access from the outside world at the moment. So this is what I wanted to tell you about this thing. So we are more or less finishing. So what you can see here is, as a result, and I will hand over to Mickey in a few minutes. We should adapt the KCCSS scoring, so it's quite new. So we have to learn how we really flag these vulnerabilities. And Mickey will show how to block threats like this. So we will definitely see the counter measures in a few seconds. Questions, you can send me email or ask them in the chat immediately. Some resources from my side. We have a German ISO article now. There's a presentation I gave at the ECO conference, and there's even a full hour, nearly full hour talk from the KS communication camp. So thank you, and I'm handing back to Torsten and Mickey the next.
Thank you so much, Thomas. I think you guys see what you can do and where the dangers are. Somebody asked in the chat if this notebook will be shared. There will be a recording of the whole session to be shared, and obviously Thomas will share the notebook as well.
The notebook will share. If you are familiar with Jupyter notebooks and Bash kernels, then you can use it and adapt it. And I would say if you know one of the other clouds, it's a 10-minute task of adapting them to at least to GKE, and I assume Azure and AWS are on the same level.
All right. Thank you so much, Thomas. Mickey, it's your turn. Please share, and everybody else, please write questions which you have to Thomas in the Q&A section down there. We'll answer that in the last half minute. And up to you, Mickey, please.
Okay, so thanks, Torsten. Let me just turn off my video. Okay, so my name is Mickey. I'm from Octarine. I'm in Octarine for 2 years. Previously, I worked on backend development, big data development, mobile development. So what are we going to see today? So this is our agenda. We'll go through a short overview of Kubernetes security, then some community tools for securing Kubernetes. Then we'll see how Octarine helps you secure Kubernetes, and we'll of course have a demo. It will take us a couple of minutes to get to see how we block the attack that Thomas just showed. So be patient. So Kubernetes is a game changer. It's actually, as we can see, it's in between 2 major changes. Now, these changes happened before Kubernetes and regardless of it, but some would say that Kubernetes maybe helped these changes happen, maybe it accelerated them. So on one hand, we have the tech stack. So we're moving from monolithic to microservices. Again, it happened before Kubernetes, but I guess we all agree that today Kubernetes makes it much easier for us to create microservices, to put them in production. And on the other end, we have the organizational or cultural change. So we moved from central groups of ops, dev, sec, for example, to DevOps. But actually what happened is that the ownership moved to the dev teams. So a lot of the security or dev ownership is now under the responsibility of developers. So for example, it of course depends on the organization, but developers might have control on storage resources in your cloud, on the network configuration in your cloud, etc. So we have many workloads, and the ownership for managing and securing them is distributed in many teams, and this is basically we say it's a security challenge in many cases and in many companies. So why is it a security challenge? If you go to CNCF, you'll see this diagram. And many people see Kubernetes as just another layer between the container layer and the cloud layer. But actually, if you look deeper into Kubernetes, so it's much more than just a layer in the stack. It's a really powerful layer. So we can see on the left, we listed some of Kubernetes capabilities. And you can see, if you go over them, you can see that Kubernetes can actually affect other layers. This is why we claim that it's a very powerful layer. So Kubernetes, for example, can manipulate your cloud resources. It can change container configs, and that's why it's really powerful. So this is why it's an opportunity for hackers. And the power of Kubernetes actually brings the opportunity for hackers in Kubernetes. So there are two main reasons for that. One is that many people, they don't understand how powerful Kubernetes is. So many Kubernetes clusters are left unsecured. And the second is that because Kubernetes is so powerful, so attackers prefer to attack it, because if you get access to the Kubernetes resources, if you succeed attacking a Kubernetes cluster, then you might get a lot of power, even of other layers or other cloud resources. So how to secure Kubernetes? We discussed why it's important, and this workshop is about security for Kubernetes. So I guess we all agree that it is important. We also saw earlier how Kubernetes can be hacked. So now let's see how do I secure Kubernetes. We'll start with a short overview of the built-in native Kubernetes tools for security. So we'll just do it quickly. So first we have dynamic admission controllers. Well, they can help you prevent changes in Kubernetes. So they can be validating, and they can reject or approve a change in Kubernetes. And they can also help you mutate resources. So this way you can enforce policies. And pod security policy, which is an implementation of an admission controller. It's really powerful. It's really useful. It's a good security solution, but the main issue with it is that it's complicated. I don't know how many of you ever tried configuring pod security policy, but it's not that simple. And if you're trying to configure multiple pod security policies, it gets even way more complicated to understand the prioritization, etc. But again, it's powerful and useful. We have RBAC, so of course, we should utilize RBAC to enforce access control. It also might be complicated. And last, we have the network policy. So we can use network policies to segment the cluster to prevent access between namespaces or workloads. And also network policy is not so simple to use. So what can we do with these Kubernetes features that are, some of them are complicated or requires some hard work to implement. So first of all, we have some other security tools. This is just a very short list. We have way more security tools for Kubernetes. Some of them are open source, some are not open source, but maybe community versions. So this is just a short example. Most of them are built on top, or they use some Kubernetes security features. So this is a short reference for them. But so what are the challenges? As we saw in the last couple of minutes, so we have many small tools. We just saw them. Not all of them are simple to configure and use, and it's distributed. So you need to use multiple tools in order to really get security for your Kubernetes cluster. So ownership, I'm going back to the beginning. So I was talking about the organizational and cultural change. So there is no clear ownership of the security of Kubernetes clusters in your company, maybe, or in many companies. So sometimes people that are supposed to do the security for Kubernetes, they maybe don't care, or they have other responsibilities and it's not their top priority. And people that care about the security, they sometimes don't know how to do it in Kubernetes, because you have to remember that Kubernetes is pretty new. It is complicated, so it requires quite a lot of training to deal with securing it and operations of Kubernetes, of course. Next challenge is, well, the enforcement, in our opinion, in all the tools I mentioned, is too late in the process. So we're doing the security enforcement right before the workloads are actually running in the cluster. And we say it's not enough. We see today shift left. So there's an emphasis on CI/CD in terms of security, and people are trying to do the security enforcement in their CI/CD and not and try to avoid this stuff only in production. Support for multi-cluster. So it is a challenge for security, but in general, multi-cluster in Kubernetes is a challenge. And the filtering capabilities of network policy, well, they're quite limited. So when it comes to Kubernetes, most of us get the feeling that you need a team of experts to secure it, and that's us, that's Octarine. That's where we come into place. Octarine DevSecOps Simplified. So Octarine was founded around 3 years ago, and with the mission to address the Kubernetes security challenges. So we provide solutions for Kubernetes security. So how do we see in Octarine, how do we see the security for the enterprise in Kubernetes, of course? So we believe that first you need to prioritize. So you have many workloads. Just take, Julian talked about Kube-Scan, and we're talking about Kube-Scan. If you'll take Kube-Scan later and you will install it on your cluster, whether it's a dev, staging, or production cluster, you'll probably see many workloads. And you need to prioritize, you need to rank them by the risk. That's why we have the risk score in Kube-Scan. You need to understand the risks and to understand where to focus, because you can't handle everything at once. Enforcement. So you should set policy, you should deny insecure workloads according to this policy, and you should do it as early as you can, which leads me to the next point, shift left. So again, the security should be embedded into the development process, and you should try to enforce the security policy before deploying the workloads. Delegation. So again, going back to the cultural change within companies, a lot of the responsibility is now on the teams. So you want to empower them. You want to make sure that they're developing secured applications and they're making smart decisions. For that, I'll just say that for that, of course, you need education. So you need to have good training, you need to have good knowledge base. And last, of course, protection at runtime, which is super important. Okay, so in Octarine, we believe in continuous and automated security, which is infused into the application lifecycle. As you can see here in this diagram, we have two main components. We have guardrails on the left and the runtime component. So guardrails covers the security of resources config throughout the build lifecycle, which is actually from build to deploy. And it helps with security and, by the way, also with compliance. And the runtime embeds security into your application. So it utilizes eBPF. It provides you anomaly detection and some more features. Okay, so we'll move now to the demo. Let me just change the screen I'm sharing. Just a second. Yes, so I think you cannot see my screen. Let me understand why Zoom won't share it. Okay. Okay, so now you can see my screen. So we're starting first. So I have a Minikube cluster here, same as Thomas just used in his demo. And I have guardrails installed on this cluster. So what is guardrails? It's basically just a pod running in your cluster, and it's an admission controller. So this is our dashboard. We're starting with the risk screen. This is basically very similar to what we saw earlier in Kube-Scan. Basically, it uses Kube-Scan. So you get in guardrails, you get, of course, the same Kube-Scan features, and you can see the running workloads in your cluster. You can identify the risks and again prioritize them. Now this is Kube-Scan, and guardrail has some more features on top of just Kube-Scan. So first of all, we have the policy mechanism. So we were talking about policies. Again, this is the policy is implemented using an admission controller. So here, every account comes with a default policy, and the policy basically covers a lot of Kubernetes resources configs, which are related to security. It's based on CIS benchmark. For example, you can see I can control whether I want to allow privileged containers in my cluster, and for each of these configs, I can decide whether I want to allow it, to alert, or to block it. So block will not let such resources be created, and alert will just send you an alert. And you can see I have a lot of configurations here which I can control. For example, SE Linux policy, so I can enforce that every workload should have SE Linux policy, AppArmor, etc. I can control kubectl commands, so I can block kubectl exec and cp. I can block port forward network, so I can control my network resources and decide about load balancers, node ports, etc. and many more. And one of the nice features of the guardrail policies is the custom rule. So I can define a custom rule. This can be used, by the way, not only for security purposes, but only for other operational purposes. So you can enforce anything you want on a Kubernetes resource. You can enforce, for example, the number of replicas. You can enforce the labels, and it can be used for different purposes. And once you edit, it will be part of your policy. So here I have my default policy for my Minikube cluster. What I decided to do here, we usually start with alerts. So we're usually not blocking by default, but we prefer to first alert because you don't want to cause outage and to just stop half of your workloads. But here, just for the demo, I decided to block workloads with containers that are allowed to run as root user. And I'm also blocking, I created a custom rule which will block workloads with a host path volume. Okay, so let's see how it works. It's actually pretty simple. So I have, what I have here is, I have the CloudBomb pod YAML, which is same pod that Thomas used in his demo. I just put it in a file. So I will just now apply the CloudBomb demo pod. And I can see that the admission webhook, Octarine denied the request, blocked by Octarine. I can get all the details of this block. And I mentioned alerts. So of course you get alerts for such events. And I will actually have two alerts here. So one is for running as root, and the other one is for the custom rule I created for the host path volume. And I can also click here, and it will get me directly to the policy according to which it was blocked. And that's basically how Guardrail can help you in runtime. So in addition to scanning the cluster, and again, Kube-Scan is a static tool. It scans your cluster, and it gives you the report, but it doesn't do anything to prevent such stuff from running in your cluster. And that's where Guardrails come into place. So that's how it works. Now, what happens if I have privileged applications? So we are talking about blocking containers from running as root or host path, but sometimes this is feature that our applications need, and sometimes we must, and it can happen in our applications that we develop and run on our Kubernetes cluster, but it can also happen with system components, the Kube system namespace, and of course with third-party apps. So if you install Kube-Scan later on your cluster, you will probably see pretty high risk for the Kube system workloads. And if you have Nginx, Prometheus, or any other third-party apps, you will probably get or maybe get high risk for them as well. So first of all, in general, what can you do with that? So with the system components, the Kube system namespace, you don't have much to do. You can't change the workloads there, and you don't want to do that. But what you can do is, for example, control the network exposure of workloads in this namespace. So you don't want external traffic to them. You might want to block kubectl exec. So I mentioned that Guardrails can enforce it, and kubectl exec is like it's like SSH. So we were all very familiar with SSH, and we control who can SSH to our production VMs, but sometimes we forget about kubectl exec, which can be the same. So you would want to block that to the Kube system namespace. And regarding third-party apps, so there you have some sort of control. Let's say you installed Prometheus or Nginx, so you can change their functionality, but you can change some of the config. So most of the Helm charts, they allow you to change the security context of the applications where you can do it. So for example, in Prometheus and in Nginx, you can disable the allow privilege escalation in the security context, which is enabled by default, but there's no reason to really run with this config. So even when taking Helm charts from the internet of third-party apps, you should tune them and make sure you add security to them. Another thing about most of the third-party apps is that they don't put resource limits, the CPU and memory requests and limits. So they usually don't put them, but it's really important that you do it. And again, you would want to prevent kubectl exec to them. You want to control their network exposure because they are more privileged. So now let's say that I have an app which should be privileged. So Guardrail supports multiple policies, and I can create a new policy. I can create it from a template. We have templates. We have the recommended template and templates based on the CIS benchmarks. So here I created in advance a template, a policy named privileged, which for each policy you can decide about its scope. So this policy applies to the privileged namespace only. And this is quite a nice control over multiple policies. Again, if you try to do it with pod security policy, it might get complicated. You might miss things. You might not really know which policy it will choose if you have few. So here I have a policy. You can see it's way too privileged, but just for the demo, it's allowing everything. And I just here I set it to block kubectl exec and cp. And that's it. So besides that, I'm allowing everything. And again, it's only applied to the namespace named privileged. So let's see. I will now apply the same CloudBomb pod to the privileged namespace, and the pod is created. And now I showed you that I blocked the kubectl exec. So let's see how this behaves. So I will now try to run just the shell in this CloudBomb pod. And again, this is the kubectl exec command blocked by Octarine. Going here, I will also have an alert here. I can see which user did the kubectl exec command. I can see the command arguments. And of course, you're not expected to go into the dashboard to see the alerts, but you can define notifications, so you can get the alerts to your Slack or PagerDuty or any other integration that you want. Now I was talking about CI/CD and shift left and doing the security enforcement before deploying the workloads. So we also have an integration with CI/CD tools. For this demo, we're using CodeFresh, but you can use any other tool that you might want. So I put this CloudBomb pod in just a GitHub repo, which is configured for this build in CodeFresh. I'll now commit and push this file just to trigger the build and demo the CI/CD. So I committed the file, I pushed it to Git. I now have a build running of this project. So it will take it off a couple of seconds, and we have the first step of the build. Well, after cloning it, of course, is security validation by Octarine. So what it does is basically take all the resources, or according to your config, but it will take the Kubernetes resources in the project and will scan them with your Guardrail policy. So it will match the policy that you configured in your account. And here I can see that the validation step failed, and I get the details of the failure, and I can see that I have the CloudBomb pod, which is violating 2 sections of my policy. And this is how you can integrate it in your CI/CD. which is again very recommended instead of just finding these things out in just right before deploying them. Okay, so I will show you a couple of more features of guardrails. For that, I'm moving now to another demo because the CloudBomb demo is pretty small. So I'm moving now to another demo app that we have. We have here quite a large demo app. It has, you can see it has multiple namespaces. In each namespace, we have multiple workloads, we have traffic, so it's a more interesting app. You can see here the risk page when you have a big app. So you will have a lot of data. That's why we have the risk score. So you can see here, for example, that you should probably first handle this cron and logs workloads. So this is the idea of the risk score. So it will help you prioritize and be able to handle the risks. And we have another nice view here, which is the dashboard view. So this gives you a general overview of your cluster. You can see, again, looking at the same security related configurations. I can see that I have 2 privileged workloads. I can see that I have 82 workloads without the CPU request limits and also the memory request and limits. If I'll click on it, so I can get all the details about these resources, so it can help me then handle the issue and try to solve this risk. And another nice feature is the queries. So I mentioned that guardrails can be used for security purposes, but also for operational purposes. So this is a nice example of it. So queries, they basically allow you to define queries, well, any query that you want on your resources. So again, you can, for example, query all the workloads with a specific number of replicas or with more than 3 replicas, for example. And I have here a query for workloads with missing CPU limits. So again, I can see the same dashboard screen and get all the total numbers and get all the details about the specific workloads. And I can take this custom query and add it to a policy, which will be added as a custom rule like I did before for the OSTPAT volume. And that's more or less the guardrail features. Now, I mentioned we have a runtime solution as well, and we have a runtime component. Again, it uses eBPF. It's basically tapping the network. So in addition to looking at your Kubernetes resources configs and make sure that the configuration is not too privileged, you probably also want to do runtime protection and look at your network traffic. So I showed you before, this is our activity map. First of all, it gives you, our runtime component gives you visibility of your cluster. So you can see the traffic in your cluster. I can drill down into one namespace and I can see here the traffic and the workloads, and I'll drill down to a specific workload and I can see its traffic details. So I see that it had outbound HTTP traffic and all these details. We have the egress policy, so you can control egress traffic. Again, you can decide if you want to allow, alert, or block, and you can decide what to do with traffic to public IPs and to malicious IPs and domains, which is of course a list of malicious IPs that we maintain. We have, I mentioned the IDS, so we have the threat alerts. This is the IDS. So we are running signatures, and you can see traffic that was identified or is suspicious as a threat, and you can see its exact details. And we have the anomaly detection. So the anomaly detection will detect anomalies in your traffic. So for example, unusual error rates, or maybe new traffic to a new port, or traffic with a new protocol, etc. So again, going over detected anomalies can help you avoid security issues. And that's it, I think. So I will hand it over now to Thorsten. Back to Thorsten.
So, thank you. Thank you for the journey on Kubernetes security, starting from features, main features from Gerland, and how to hack it and how to mitigate that. Thanks a lot, everybody. Now, please feel free to ask questions in the Q&A section, F&A if you have a German one. We have already some questions, and I would say we'll do a panel and go around, and we'll start top down with the question. I'll start with the first one. There was a mention around scanning PII data. Can you talk a little about this? I think this is for Gerland. Could you elaborate on that?
Yes, so the scanning with that, it's not that Kube-Scan is specific to and looking to such kind of data, but this was mentioned if your workload is processing such kind of data and it is at risk at that level, this is going to be the way how you are going to actually identify that, and to be sure that there where you are processing personal identifiable data, you are at risk, and you have to mitigate those risks and to take the necessary countermeasures. This is what was meant by that.
Okay, thanks a lot. Next question is, are exceptions per pod possible if an application, for example, has to run as root?
So, yeah, I'll take that. So I think this was asked regarding Kube-Scan, right? So,
yeah.
So in Kube-Scan, currently no. Kube-Scan is again, it's more like a static tool to get a static report of your cluster. Well, it's an open source, so you can do anything you want with that. But I think that exceptions are more important where you enforce policies, and that's what I showed in guardrails.
Okay, thanks.
I would like to add something. If you need mitigations per pod, then your architecture is probably not set up very well. So you should need mitigations per namespace, and this is something I would like to add. Simply make your application, even if it's distributed in several microservices, as simple, auditable as possible. And what we show here is it's wonderful that we can mitigate it, but it would be better if you would start in the beginning, separate namespaces. Here you have the privileged things to do. You can monitor them. And here in this user namespace, let's say there are no privileges, there are no ports with root access, something like this. It's possible to do this. It's a little bit of work in the beginning. It's not programming, it's architecture. Thanks.
Thanks. Next question is the container technology relevant, like Docker, RKT, and so on? Who would want to take that from the speakers?
I would like to continue. Yes, it is a little bit, because CloudBomb would not work on something else than Docker, but also Containerd has sockets, so you could change it to KCCSS or other things. It's not as relevant as it looks like. As long as we have access to the host file system, you have definitely that problem.
Okay.
Yeah, just add on that. So, because if the question is about Kube-Scan or guardrails, so no, basically the tools are based on on Kubernetes, and they're using the Kubernetes APIs and not the container technology.
Okay. Can the use of Kube-Scan be limited to certain namespaces? Mickey.
Yeah. So again, it relates to the first question, I think. So currently, no. Again, Kube-Scan gives you a static report of all of the cluster, but again, it's an open source, so actually limiting it to one namespace is pretty easy.
Okay. Is Kube-Scan, checking for currently active threads only, or is it also looking for potential threats? For example, the security policies allow the usage of root users within containers. Maybe Jerlin, you want to take that one?
Yeah. Again, so I think it was mentioned many times now that Kube-Scan, it's just a static tool, so it would look at the configurations and not on the runtime, meaning on active threads. So for that, you would need different tools, as Mickey was actually showing, and different kind of mitigation and controls in order to monitor active threats. So this is something that you cannot do with Kube-Scan. It would just provide you the settings, how your workloads have been configured.
Okay, thanks. Question, is there a possibility to export findings from Guardrails Kube-Scan in a generic way to import them into my Acme SIEM solution?
So actually, that's a good idea. No, currently there's no exporter, but we're always glad to get some feature requests, and we're happily implementing them.
Okay. Next one, is the actual HTTP between pods also tracked and can be used for application troubleshooting?
So yeah, so that one is for me. So yeah, you can see the actual HTTP traffic. You can get details on the port, on the method, and the endpoint. Now for application troubleshooting, so it depends. Remember, we are a security tool. We provide security solution. So I'm not sure if it's the best tool for debugging applications. It might help in some cases, but it's not built for that specifically.
All right. Are there any more questions from the audience? So far, let me have a look. We have, there is another one.
None.
Can you point to any docs, if available, to integrate with GitLab CI?
Yeah, so the CI/CD integration is part of Guardrails, not Kube-Scan, and we have integrations with I think most of the CI tools, but that's for Guardrail users. So we are happy, by the way, if anyone wants, we are happy to. We'll be doing POC for sure. You can contact us later on, and we can schedule a POC. We can install Guardrails, new cluster. We can do a POC for the CI/CD integration with your tool, if it's GitLab or any other tool.
Okay, and another question: how does Octarine compare to Twistlock or added features in Octarine?
Okay, so yeah, so Twistlock, some would say they're competitors. I'm not quite sure. So Twistlock, from what I know, they're focused more on container security. So they are working, I think, on like more Kubernetes specific solutions. But currently their solution is more for container security. And again, we're doing Kubernetes security. So for example, I don't think they have something like Guardrails. And the big advantage of using us also for the runtime is that we are Kubernetes aware, and we have the context of Kubernetes. You have all the details of your workloads. You see workload names, and it's because we're looking at Kubernetes and not only on the container level. And that's I think that the main difference between us and Twistlock. So again, we are more Kubernetes aware. We are a Kubernetes security solution. We give you the Kubernetes context, and this is something that you will usually not get from containers security solutions.
Yep.
Okay, thanks. As there's actually no question from the audience right now, I have a question, and I would give that around to the panel. We're talking quite a bit on Kubernetes security. I know adoption is rising on Kubernetes. And for all of you, how much do you see really attacks, breaches on Kubernetes clusters? Is it so far more theoretically, or are there really big breaches already? And I would start the way we started. So Gerland, Thomas, and then Mickey. Could you just give me a short overview how you see the whole environment right now and the attackers?
Yeah. So there have been many attacks in practice, also on big companies running or using Kubernetes as platforms. So Kubernetes, as also Mickey mentioned, it's an enabler for doing the DevOps, let's say, concept, or the DevOps way of doing things and integrating this into your company. So it enables you for that. And as it is also a complexity added to your environment, of course, it's going to be a door for attackers into trying to use and to exploit that. And as we saw by Thomas in the demo, he already showed an attack that this can be even easily used as so-called script kiddies, and that it works on Kubernetes environment running even on Google on the GKA. So for sure, this is a very hot, important topic you need to be aware of.
Thanks, Thomas.
Yeah, actually, it's so easy if you ignore the most common security settings. The script kiddies are knocking at the door. At the moment, we have not seen very big things, also very big attacks. But what we have seen is that you can scan Kubernetes on Shodan if you have even done the basic things wrong, so no HTTPS access to your cluster, but HTTP, then probably you get a visitor very soon. What we've also seen is that on Docker Hub, there have been images for nearly a year, which have been done, not a Bitcoin, some other currency mining. So this is real, and the security is more important as now Kubernetes enters really critical infrastructure. This means traffic, healthcare, energy, and anything what is critical, business banking. And people need to be aware of this, because here we apply regulations, and you cannot run a Kubernetes cluster in the very naive way. We have done it a few years ago, so we need higher levels of security in that environment, and therefore it's important. On the other side, the basic setting of Kubernetes does not include security, unfortunately, and what we've also seen, this was part of the last talk, is if you apply pod security policies, more or less all your stable Helm charts break. So there is a big misfit between the easiness of deploying an application and security on the other side. And we have to close this gap. And we have to close this gap quickly. Otherwise, we will run very important systems and will be surprised what hackers can do in the near future.
Thanks. Mickey?
Yeah, so I think, I mean, it's hard for me to tell about the rates of Kubernetes attacks, but I don't know, it exists. There was, for example, I think it was a cryptojack attack on Tesla. And whether it exists or not, you don't want it to happen on your cluster. And it's true that many companies are now in the stage of shifting to Kubernetes, of migrating to Kubernetes. And I think that in this stage, it's really important to start thinking about security. So for example, start defining your policy, make sure that workload that you deploy, you start with them secured. Well, it might require a lot of resources to secure your workloads, but if you do it at first and you start with small steps, you can get a good base to start with. And it's much easier to set a policy now, for example, and follow this policy and make sure that you're not running every workload as root, because this is something which is very common. We see in a lot of companies. They have clusters with maybe tens or hundreds of workloads. They might all be running as root because that's the easiest way for the developers usually. That's the easiest way for the things to work. So they're running everything as root, and then go back to applications you developed for a couple of years and try to fix them all and try to change them all to not run as root and give them just the required privileges. This can be a nightmare to do it. This can be a serious project. But if you start and when you start migrating to Kubernetes, so start thinking about security. Again, start with the education of the team with a good knowledge base and small steps, and just make sure that you're developing secure apps from the beginning.
Okay, thanks. I have another question which comes from the audience, from Simon, who says, would you consider Kubernetes to be more vulnerable than a classic VM-based setup?
It depends. Actually, so this is part of one of my longer trainings or talks. In the beginning, we have seen attacks on virtual machines because memory management units and CPUs are so complicated that you can trick them out to get access to a different workload. In my opinion, if you do Kubernetes right, you can get a higher level of security than on standard systems, because you have a distributed system. All the systems are set up equally, and you have a central point of control. But on the other side, if you lose this central point of control to the enemy, then obviously it is very powerful. So it's goes into both directions, and the old rules are not wrong. So don't run an unknown software as root on your critical infrastructure, and it's not necessary. What overwhelms me is the unnecessity of things I've seen in the wild. So standard is run things as root, as Mickey mentioned. And you can make it more secure. You can even switch on what we did not have as a topic here, audit logs. So it can be very, very secure. But on the other side, you have seen the default settings are so insecure. You should be very careful in critical infrastructure.
Okay,
yeah,
thanks.
Maybe I'd like to add to that, saying that we are talking also again here from a different layer perspective, and as Thomas put it, it depends, of course, on your security requirements that you need to address. It doesn't mean that you should use either one or the other. You can even use a combination of them. When it comes with VMs, you will have the complexity of taking care of an operating system, of a guest operating system. So this would add to your complexity in general. So this can be a security drawback for you, because then you have a more complex system that you need to take care of. When with Kubernetes you have this single point of failure, but it doesn't mean you can maybe separate this into different VMs, different clusters. So depending on how you architect your environment, so you need to be aware what is your threat landscape, who are you protecting against, and how you do this from from the beginning, as Miki said, even from the development, on the right strategy and to architect this and to do security by design and security in depth and looking at all these layers.
All right. There's another question from the audience. Do you consider it a problem that many official Docker images of open source projects are said to be used whenever possible, are violating basic security rules, like not using the root user to be security compliant? You often have to rebuild a lot of images. Miki.
Yeah, so I think before going to rebuilding images, which I agree, it's a lot of work. So I'm not sure it's required. We are looking again at Kube-Scan and at guardrails. We're looking at the Kubernetes resources config, which gives you another layer of configuration and control of security on top of the container. So I'm not sure how many containers are specifically running as root, rather than Kubernetes just you run them as root in your Kubernetes. But it depends on the app. So again, as I mentioned earlier, for example, a lot of third-party apps allow you to control the security context within the Helm chart. So for example, you can limit the privilege escalation. You can also, by the way, sometimes change the user it is using. You can limit maybe the capabilities it asks from the system. And again, as Thomas mentioned earlier, if you have an app which requires more privileges, put it on a different namespace, set a policy for this namespace. Make sure you have a right Arba config for this namespace, maybe, and control who can access it. Yeah. So there's a lot to do before changing the actual Docker image.
Okay.
And actually, in any project, we have to look into what's downloaded from external sources. So this covers Docker images, but also, and don't forget it, Helm charts. And if you go deeper into the ecosystem, it also covers Python packages imported for building these images. So there's an entire tail of things you have to cover. And then if you have this set up clean once, then you get a clean container image. And this can also be built into your CI/CD pipeline. And that's a challenge I think, which has to be handled in every security critical project, that you have to control the build chain of all your applications. And tools are helping on that, but it's not only that, but it's definitely Kube-Scan and is giving you a hint into the right direction. And if you control the entire deployment pipeline, then that's great. This is what you should aim for with guardrails.
Okay, thank you. I would like to take the chance and invite you for our next meetup, which will take place in 3 weeks. We'll do it again a little bit later. So we have a global audience right now with the European time. We only have, I think, lots of Europeans, maybe some people who are from Asia. May 28th, 6 p.m. If the audience, if anybody has a topic which we should dig in deeper, where we should go into, please let us know. We'd love to talk. Please let us know as well, so we can integrate you with this. With this, I would take a last question round. I would take a question, and maybe we'll do the last round of answers with our panelists, if there's no other questions from the audience. Seeing the adoption rate of Kubernetes and seeing, I'm coming from the old school of web security, and with the perimeter, with the firewall, with DDoS protection, with bot mitigation, with all this kind of stuff. How far are we right now on security on Kubernetes? It's a tricky question, I know. So maybe we'll do it around again, Gerland, Thomas, and Mickey.
Yeah, for me, as long as you have an holistic view on security and you understand your environment, what is in your running on your network, what kind of devices are running, what kind of software appliances you're running, you have to think on all of these tools that you mentioned before. So it's the combination of them providing you a higher level of security and maintaining that security, and it's not a specific tool. So with Kubernetes, integrating all of this into one is of course challenging first to understand where maybe to start or where to put or which tools to use in the beginning. So and I think there are a couple of let's say resources where you can have a look into it and try to get your hands on and to get this understanding.
Yeah, so if you look back into history, this looks like Linux in the early 90s. So I feel whatever, 25 years younger now with Kubernetes, but it was obvious that it will succeed, and we had all the same questions at that time. Is it more secure than the other Unixes at that side? So there have been DEC OS F, Solaris, HPUX at that time, and finally the answer was yes, it is more secure. But it is a long journey, and the journey has just started. What we do at the moment is we have the first recognition even from standardization organizations. So we have tools from the National Institute of we have documents from the National Institute of Standards, the NIST in the US, from the Cloud Native Compute Foundation about DevSecOps, and we have now in May the first tools from the German Bundesamt für Sicherheit in der Informationstechnik, so the Federal Bureau for Information Security, and they now recognize, oh, we need something for containers, and it's really useful. So it's going now into that direction. We need governance and we need security in our processes, and then we will accept Kubernetes as one additional layer, like we have accepted the virtual machines a few years ago, and then in a few years it will be standard. But at the moment we are in a transitional process, and governments means, for example, to tell developers you should not run in our company containers as root and things like this. So this is a state of the art at the moment, but we will definitely have, with tools like WireGuards, we will have better security in a few months or years. That's my my statement here.
Mickey.
So first of all, I really agree. It's a journey. So Kubernetes is still a new technology. It's complicated. There's still a gap. I mean, we're probably still not there in terms of securing Kubernetes, understanding how to do it, and of course actually doing it. A lot of companies are not doing security for Kubernetes well, but it is a change that is happening. I think we see also in certifications. So I think if I'm not mistaken, PCI had to make changes to adapt to Kubernetes. So it's happening, and Kubernetes is widely adopted in many companies, and I think there's no doubt that this is the future. So again, you should start whenever you can. Start by learning Kubernetes. It's more than just running a deployment. Start by understanding what it means that you have pods running as root, or what it means that you have pods accessing your host file system and stuff. And I was also mentioning knowledge base, education. So these are things that are currently developing, and yeah. So I guess we'll gather. I agree with Thomas. Maybe couple of months or years, but yeah.
Yeah.
All right, I think this was a good conclusion. I would like to ask everyone to contact us if you guys would need to help with your Kubernetes security questions, either as a POC or with Kube-Scan and with workshops and education, like Mickey said. We're out there to help. And 2 hours ran like nothing. Gee, it's last time we had an hour and it took 1.5 hours. This time 2 hours. It's a great time. Thank you so much to the audience, panelists, for giving these great speeches. I think this gave more insights in what Kubernetes security can do and what it is and what you have to secure. So have a great day and hope to see you all on May 28th. And hope stay safe and stay healthy out there and don't catch the virus. Thank you. Bye.
Bye-bye.
Thank you.
Bye.
Bye.
Bye.